All right, hey Mallory, we are doing the second half of 7-2 notes. We started with population means yesterday, and now we're going to be doing some of the same stuff. So, confidence intervals to make decisions. Shush. There's a big long paragraph here. I'm going to read part of it and see what it is that we are doing. It says that they are talking about the average number of, the mean cottoning level in each of the three samples, in people who smoke, in people who don't smoke, and in people who don't smoke but are exposed to smoke. So we're talking about three groups: the non-smokers, the smokers, and the secondhand smokers, right? Okay, these are the three groups, and we're talking about the average, underline that or circle that, cottoning levels, which is like not nicotine, but like a subcategory. And we're trying to figure out if those three groups have an equal amount of, are exposed to an equal amount of this cottoning level or whatever, right? Okay, so when they do that, like this is what we find when we're doing like our mu, we're finding what two numbers he lives in between. What they've done is they've just taken those numbers in each of these three categories and they've put it on a number line, all right? Now, here's what we find. These are people who are not exposed to smoke, so these are non-smokers. Okay, here are the smokers, and here are the like secondhand smokers, the people who are exposed to smoke, okay? From these calculations, we see that this like grouping, the smokers, that is not even overlapping with the non-smokers, right? This group right here is completely off to the right side because it does have an elevated cottoning level. Do you see how that works? Okay? And the fact that it is not overlapped, like these two are overlapped, right? So we can maybe make an argument to say that like secondhand smoke, you know, people who are exposed to secondhand smoke, you know, it's not that big of a deal. But the fact that the smokers are all elevated means that the cigarettes are increasing the amount of cottoning level in their blood or whatever it is that we're testing, right? These are conclusions that we can make. So when we figure out that those two numbers that mu lives in between, we can put like multiple ones together on a number line and compare them, right? Okay, that was one question that they had on your homework assignment, like number 4, like the last part, right? It said like, how does it compare to, you know, the previous stuff or the previous results that we got, okay? And you're looking to see whether those intervals overlap or not. All right, let's go down to this one right here. Determining sample size. So we did this in 7-1 also, okay, where we calculate the error, right? Error for 7-1 looked like this, right? And they would give us, they would say, I want to be off by like 5%. So we put 5% in there and we're solving for n, like we're working backwards. This does the same thing, except your error is calculated by t times s over the square root of n, right? Okay, now here's the deal. Here's the deal. This formula right here, they have undone it to solve for n, right? Like you would divide by t and you take and you square it and do all that stuff. This undoes what this error formula did to solve for how many people we have to sample. But what is different? It's squared instead of a square root, right? Which undoes each other. But what else is different?
Something on the top there. Something looking wide.
Okay. They call this, this is what S is, so like your standard deviation, right? But instead of using T, they use Z, okay? Now, the reason for that is when we're using T, when we're using the T chart, we have to know the degrees of freedom, right? But what's the degrees of freedom based off of?
T?
If you're trying to find T, what's your degrees of freedom based off of? N, but if we're solving for N, how do we know what T is? So instead we use that Z value. We use the Z value instead of the T value, right? Okay? Because we don't know what N is, so we can't find T, right? So here's the deal. All right, here we go. Assume we want to estimate the mean IQ score for the population of statistics students. How many stats students must we find, or how many people do we have to survey? That means we're solving for N. If we want to be 95% confident, and I want to be within 3 IQ points. What does the 3 mean? Shh.
That's the margin of error.
That's the margin of error. I want to be off by 3 on either side, okay? All right. If you want a small error, how many people do you have to survey?
A lot.
A lot. If you're allowed to have more error, you can be lazier and not have to survey as many. You girls in the back, be quiet. Error is 3. So I'm going to do, and I'm just going to solve for n, right? N equals, we have to know z, we have to know s, we have to know error, and we're going to square it.
For S or Z times S?
Z times s.
Okay.
Yeah, z times s. Okay. Do they tell us what our standard deviation is? How many stats students must randomly selected for IQ sample mean that's within 3 points? They don't tell us what the standard deviation is.
Solve for it.
And we have to know that. No, we can't solve for it because we don't know it.
Okay. Then we can do it.
I think we left off some information here.
Just make it up.
Let's make it up. Let's say they gave us a standard deviation of 0.5. Let's say our standard deviation is 0.5. They have to give that to you, okay? For some reason, I left it off here. I don't know. Maybe I typoed it or something. All right, n equals. Okay, we have to find z. What is the z value? What do we look at to find z?
On the chart, 95.
95% on the z chart.
1.96.
1.96.
Yep.
Okay, standard deviation is 0.5, and the error is 3. Do we move the decimal on the 3?
No.
No, it's not a proportion. It's an actual number, okay? And then we do that. We have to figure out how many people we have to survey. How many people do we have to survey? Is that right? That shouldn't be right.
You're right.
What is n?
Hold on. I got 0.105.
That should not be right.
But I didn't put parentheses around the square. Hold on. Well, I did put parentheses.
Because then that means we don't have to survey very many people.
0.107.
What?
0.107.
0.107? That means we have to survey 1 person in order to have an error of 3.
Well, I think your standard deviation is throwing her off.
What should we use as a standard deviation? I don't know.
0.1. No, a bigger standard
Maybe it has to
deviation.
like a whole number.
2.
Like a 10.
Standard deviation of 10? Okay, let's do a standard deviation of 10. So we'll put 10 in that spot. I don't know. I'm picking random numbers and my random numbers are not working.
42.7.
So now if you do it, you have to survey 42.7.
Yeah.
Okay, so if we want an error of 3, we have to survey 43 people.
That's your. Oh, what?
Yeah. If our error is going to be 3, we have to survey 43 people.
But they're going to give us a standard deviation.
They have to give you the standard deviation. I just picked a bad number for standard deviation.
All right.
So they have to give you that. They have to give you that. I don't know. I must have like mistyped it or something. Anyway. Okay, good. All right, next. This last part is calculating the error when we use the z-chart. Okay, so let's talk about, again, when we use the z-chart versus t-chart. So t versus z. Okay? And it has to do with n usually. If the n is less than 30, we use t. If it's greater than or equal to 30, we use z. Okay? Yeah? Or, if this is known versus this is not known. Okay? Usually you're looking at n though. Okay? Usually you're looking at the n values. So small n values, you're going to use the t-chart because they give you degrees of freedom. Big values of n, you're going to use the z-chart. Okay? Here we go. So this last part is going to be the same formula, same process, but now we're using z's instead of t's. Okay, so example 5. Use these same 15 birth weights, but now we know the value of the standard deviation to be 2.9. So it's not S, it's sigma. So that means we get to use the z-chart, right? Our n is still less than 15, but we know what our population standard deviation is. So we get to use the z-chart, okay? 95%. Shh, you girls in the back, be quiet. 95% z 2 point, what? 145. Are you sure? Z?
No, 1.96. It's 95.
Or 90?
Looking at T, I thought we said T.
Oh, 1.96. Okay. N is 15. X bar is 30.9. And, oh, standard deviation is 2.9. All right, so error is z times the standard deviation over the square root of n, and we're just going to plop numbers in. 1.96 was z. Standard deviation was 2.9. N was still 15. What does that give you for a margin of error?
Is 1.487.
1.47. Okay. When we did this problem before, your error was 1.6. Yeah. So it just changes it slightly when you use the versus t. Okay. Now we have to find where mu lives in between. So like what two numbers does he live in between? How did you find that?
That's the average.
Our average is 30.9 and my error is 1.47. So I add and subtract. What'd you get?
Subtracted.
32.37. What?
Subtract is 29.43.
29.43 HGs. Okay, so just slightly changes my range from what we did in the first example or something. Okay, good. All right, and that's it. Okay, let's go to your homework real quick because we got to talk through a couple things here.
Why do you have to erase that?
Because. Okay. Just some notational things. They're going to ask you stuff, and it's like not asking you a hard thing, but just the notation of stuff that they give you. They are giving you the answer, by the way. They are giving you this, but they write it as a parentheses rather than writing it like this. 13.046. Put this down on number 1. They're writing it with parentheses rather than writing it like that you are used to seeing. This is part, hold on, this is part A. Kind of. Express the confidence interval in the format that uses less than symbols. Okay, so you should have written it down there. Sorry. Given that the original listed data uses 1 decimal place, round the confidence interval limits accordingly. So they're saying, go ahead and write it like that, but do 1 decimal place. So
Oh my gosh.
they're saying use 1 decimal place. Okay. So what are our two numbers going to be?
13 and 22.2.
13.0 and 22.2.
Actually, it would be 13.1.
No.
The 4
No.
rounds to 5 and the 5 rounds to 9.
No. You don't look at what the 4 rounds to. You only look at the 4.
Okay, fine.
Right? Right?
Fine.
I don't.
We could do
I
it your
think
way.
Marcus might be right.
No.
We can do it your way.
No.
I get it because
You're not rounding twice. Yeah.
I know.
You're only rounding it to 0. Anyway, so there's that. Okay? So that's why they gave you a weird notational thing. Okay. Identify the point estimate of mu and the margin of error. Okay. What helps me estimate? What one point estimates mu? What one thing estimates what mu is?
The average.
The average, which they call what?
X bar.
X bar. So they want us to find what X bar is, and they give it to you, right? Is 17.6 actually. Okay, and if that's the case, what's the error? 17.6. Does 17.6 live exactly between these two?
We don't have to write it in one. That's
4.6.
4.6. Is that what you're adding and subtracting each
No,
time?
we don't have to write it in one decimal.
Yeah. What?
We don't have to write it in 1 decimal, so our error's going to be thrown off.
I don't care. I don't care.
Okay.
I don't care. You can put it as 1 decimal, or you can go back to these numbers and figure out what that is, right? For your error. Okay, got it? They just wrote that stuff in weird notation. In constructing the confidence interval mu, why is it not necessary to confirm that the sample data appear to be from a population with a normal distribution?
Give us everything.
Don't worry about C. We're not going to answer part C. Okay? So there you go. I did number 1 for you. Perfect. Okay? All right, you go through and do the rest of them. Yeah, there you go.
Great.
Okay? You have lots of time to work. Like 20 minutes. Start so I can answer questions. Start so I can answer questions.